time in, or are we going? All right. Hi, thanks, everyone. I'm Brian Kester, for those of you who don't know me. This is the Milwaukee Atheist Skeptics and Humanists meetup, sponsored by Mythicist Milwaukee. And there's a lot of familiar faces in the group. For those, I just met Trey, that might be new. We're a free thought group. Tends to be atheist agnostic as a whole, but not limited to that. If you call yourself a free thinker, you're absolutely welcome. So there's no labels or definitions you have to pass. We seek to kind of educate the free thought community with these kind of like informative socials. They tend to be back and forth. So Caleb will be presenting today. It's not like interruptions, questions, raising hand is all good. That's what we want to do here. We just got done with a big debate between Bart Ehrman and Robert Price. So if you were there, really fun. A lot of people. We tend to do bigger events. We've done 4 of them so far, where we brought in either debates or just free thought speakers and create a convention that way. But also every other Tuesday night we have this, and we try to get people in the group that have researched the topic to present. And Caleb's going to be presenting tonight on Bayesian probability. Caleb describes himself as, I think, believes in the God of the Bible, but is a very free thinker. We're really glad to have him here, too. So, and here, I think that we're allowed to question anyone's beliefs, but generally the culture here is that free inquiry is the one thing that we're really standing for. We don't want any impedance of free inquiry. So in that way, Caleb is absolutely good at that. Like I wish that all religious people would think exactly like he does. There'd be a lot less friction. So you're allowed to challenge in that way, but the culture, it seems, is we don't want to pick fights. And I'm really looking forward to this talk. So Caleb, fire it away. I hope I didn't miss.
No, yeah, that was pretty accurate. All right. So for those who don't know me, again, my name's Caleb Madrigal. Just so you kind of, to give you a bit of background on who I am, or what my background is. So by day, I'm a software engineer. Is this a little loud? Yeah. How about? Yeah, that's better. Okay. So, I do a lot of security-based stuff, hacking kind of stuff. I also am really interested in math and data science and that kind of stuff. What I like, and that's why I'm into this kind of stuff. I'm, wanting to maybe do some robotic stuff, but it's also just fun. Math is just fun. I used to not think that, but I do now. So as Brian mentioned, I do describe myself as a believer. I am a believer. Please give me the benefit of the doubt and don't think I'm an idiot because I believe. And of course, I do the same for you. I don't think you guys are idiots because you're atheists. I've looked at a lot of the evidence, and I can totally see where you guys are coming from. I'll admit, it sounds pretty crazy to say I believe in a invisible, all-powerful God who I've never seen. But, and I've had a lot of discussions with people, with atheists and other Christians and stuff, and I've come to the realization that whatever ontological, worldview you have, it's going to sound pretty crazy. So, for example, let's say there is no God. Well, obviously, there's some crazy views like the Boltzmann brain theory that we're just a brain and random fluctuations somewhere in outer space. There's been the matrix theory, the computer simulation theory. That one's kind of been rising to prominence recently more. Elon Musk recently said it's like 1 billion to 1 odds, he thinks, that we are a computer simulation. And there are active researchers trying to prove or disprove that hypothesis. I actually just read that there's like a billionaire who's investing like hundreds of millions of dollars to try to break out of the matrix and, I don't know, get access to the admin console. But either way, kind of some pretty crazy sounding stuff. But okay, let's ignore the theories that say what we see is not real. And what we're left with is God created the universe, or it spontaneously came into existence out of nothing, or it's always been here. And those sound pretty crazy to me as well. So what I'm kind of getting at is there's a lot of crazy sounding hypotheses, and we also don't have a lot of information, sadly. And often when we're in this situation where we don't have a ton of information, but we're trying to say what we think the case is, what reality is based on limited information, we should be careful not to be overly confident in what we say. We have to remember our limited information. So let me give you an example. I recently got jumped by like 3 Baptists on my doorstep, and they came and they asked me, well, do you know you're saved? And I said, yeah, I'm a Christian, and do you know you're saved? And I said, I trust God that I am. And they said, but you got to know, and I said, well, it depends on what you mean by know. And it sounds kind of like a philosophical answer, but if what you mean is know something with 100% certainty, I can't say that I know anything with 100% certainty. I mean, almost anything. And I gave the analogy that, look, if all of my senses are, all of my physical senses, I can read them by my brain because of electrical stimulations coming through my nerves. And those could very well be simulated by a computer, and if they were, I wouldn't know it, right? And that's kind of the matrix theory, by the way. Not exactly. The whole we're in a computer simulation theory is that we are actually computer programs, or part of a program. So not quite the matrix, but so my point was I can't say I know something with 100% certainty. Limited information, and that's kind of where Bayesian probability comes into the picture. So Bayesian probability is it's a form of probability, so it's about making reasonable, acting reasonable and believing reasonable things under lacking information. And as I said, I'm interested in AI, machine learning, all that kind of mathematical stuff, and that's where I got into Bayesian probability. And it just kind of occurred to me one day, it's like, trying to find reasonable things to believe in based on limited information. Well, that's like, religion, atheism, all that kind of stuff definitely fits into that. So I thought it would be an interesting application. So I want to ask the question, who has heard of Bayesian probability prior to coming to this talk or prior to seeing the topic? Okay. Maybe about half. How about prior to the Erdmann price debate? About the same number. And I don't know if you guys caught that, but one person asked the question in the debate, something about Bayesian probability, and it was a thing where I think Robert Price said, I'm not smart enough to understand that or something. And Erdmann mentioned he mentioned Richard Carrier uses Bayesian probability to try to argue for atheism, and he also mentioned some other Christian who uses Bayesian probability to try to prove there's a God or something. So I'm not going to be trying to do that tonight. I'm not going to be trying to do math equations and say, there's God, or something like that. It could be worthwhile to try to do something like that, but honestly, and we'll get into some of why that's difficult to do. But there's a lot of assumptions. There's so many variables. There's so many things that each person has, so many data points that each person has. I have a lot that you don't have, and you have a lot that I don't have. Experiences, observations, maybe from just thinking and through philosophical things. There's all kinds of data points, and they all influence each other. And we'll get into that a little bit more. That's the intro to Caleb. There's my website. After the talk, you can feel free to email me if you have any follow-up questions. So before we get into the details of Bayesian probability, I wanted to start off with a probability question. So I'll just read this. Suppose you're on a game show and you're given a choice of 3 doors. Behind one is a car, and behind the other are goats. You pick a door. Let's just say door 1, and the host, who knows what's behind the doors, opens another door, let's just say door 3, which has a goat. He then says to you, do you want to pick door number 2? And so the question is it to your advantage to switch or stay on the original door that you picked, or does it not matter? Now, this is assuming, by the way, that you want the car and not the goat. So just one, assumption to clear out of the way. So that's kind of the question. And you could probably do this without paper, kind of just in your head. But I'd like to kind of just see with a show of hands. So who thinks it's best to switch? Okay. Who thinks it's best to stay with the original door? Okay. And who thinks it doesn't matter if you switch or stay? Okay. Let's see. We'll go in reverse order. Those who think that it doesn't matter, could you explain why? And you don't have to if no one wants to, then that's fine. But anyone want to give their reasoning? Yes?
Classic response.
Sure.
That I know that there's one car behind all those doors, and that hasn't changed.
Yeah.
And so the odds that I pick the door that has the car is still the same out of the number of possible doors.
So you still have a 1/3 probability. Okay. Those. Oh yeah.
Once you remove the other, you only have a 50-50, so it doesn't.
So then it doesn't matter. It's 50-50 probability. It's better probability than when you started, but it's 50-50, so it doesn't matter.
So your odds increase by 20, whatever.
Right.
17%.
Right.
Yeah. But they also, so it's 50-50.
Okay. And then there's someone who believes that the best choice was to switch. Anyone want to explain your reasoning? Yeah.
Well, you stated one assumption that the host has to know where the car is.
Bingo.
So he's always going to pick the door that doesn't have the car.
Yep.
Which means in your original choice, you had a 1/3 chance of picking the car and a 2 out of 3 chance of not picking the car.
Yes.
So now that 2 out of 3 chance is all on that one door.
Right. That's right. And that's the correct answer. But it really depends. It really depends on that big assumption, right? So the host who knows what's behind the doors, and the assumption is he's not going to just open the door that has the car, because then he's going to ask, do you want to change which door you want? And you'll be, but yeah, I'll take the car. It doesn't make for a very exciting game show. Now, if he didn't know, if he did actually randomly pick one of the other doors, then it would be a 50-50 probability. So that assumption is crucial to understanding the correct answer. And this is called the Monty Hall problem after, I guess, the Let's Make a Deal show. And it's just a kind of a fun probability problem because it's one of the most controversial. Here asking the question, we get people believing each of the 3 different responses. But there's this newspaper column called Ask Marilyn, and she was asked this question and she gave the answer. It's 2/3 is better to switch. And man, there's this huge outlash, all these PhDs and stuff saying, I guess women do math differently than men, you blew it big time, misogyny like crazy. And obviously history has shown that she was correct in this assumption. She supposedly is the highest recorded IQ, by the way, so it seems like a bad idea to call her an idiot. But some people did. So anyway, that's kind of just it's an interesting problem, and it highlights, again, the importance of the assumptions that you have. Talking to people, I've often found people seem to be able to use logic reasonably well and be able to make logical, steps, and often it's the assumptions that mess people up. And it's very, very important in Bayesian probability as well. Okay, so intro to Bayesian probability. Bayesian probability it's called Bayesian because it was created by this guy named Thomas Bayes back in the 1700s, I think. And anyway, it's basically first. This is the formula for it. P of A. It's called Bayes' rule or Bayes' formula, and this is what basically all Bayesian probability is based upon. This is kind of like the kernel, the crux that everything else is built on. And it says the probability of A given B. By the way, that notation is for conditional probability, and so what it means is what's the probability of A given that we know B is true. So conditional probability could look like what's something that's unconditional. If you might, well, it's unconditional if let's say A is the probability of rain tomorrow, and B is someone in China ate rice today, something like they're unrelated, but something that's conditionally dependent, like what we're talking about here, is something like what's the probability of someone carrying an umbrella in Chicago given that it rained today, right? Much higher probability that they're carrying an umbrella given that it rained today. It's the probability of A given B, and to find that we can find the probability of B given A times the probability of A divided by the probability of B. We'll get into what those mean in more concrete terms in just a second. But I wanted to read this little quote from Wikipedia. Broadly speaking, there are two views on Bayesian probability that interpret the probability concept in different ways. According to the objectivist view, the rules of Bayesian statistics can be justified by requirements of rationality and consistency and interpreted as an extension of logic. By the way, it'd be kind of like, often logic is like a syllogism, it's deductive reasoning. Bayesian is inductive. And then according to the subjectivist view, probability quantifies a personal belief. And that's, again, why I'm kind of presenting this topic. It's talking about personal belief, whether you believe in God or whether you believe there isn't a God, or whether you're not sure. It's a personal belief. I haven't researched both of those topics in depth, like objectivist versus subjectivist. I mean, it seems to me that they're actually very close to the same. I would take personal belief as you're considering variables that aren't visible to others or something. I don't know. So it seems like, either way, however you take it, it seems like it's about reasoning. And it's something it's interesting because I think it's how people naturally think. I recently saw an article, it's a white paper, a research paper written that was trying to make the case that humans as a whole act as a distributed Bayesian network. We'll get into Bayesian networks in a minute, but that was kind of cool.
So you could use like Bayesian probability to like figure out, should I trust someone?
Mm-hmm.
Because that's an intangible and you're trying to get rid of it.
Yes, you could. Kind of like one of those pro-con lists, but a little bit more rigorous. So this is another view of the of Bayes' rule. So substituting A and B for hypothesis and evidence. And this is how it's usually used. So the probability of a hypothesis given evidence equals the probability of the evidence given the hypothesis times the probability of the hypothesis divided by the probability of the evidence. Or to draw it a slightly different way, in this case D meaning data, the probability of a hypothesis given data, blah, blah, blah. And so here's what it kind of gives you. There's two big terms that I want to highlight, prior and posterior. These terms are used everywhere in any kind of Bayesian probability literature. And what they mean is, so this right here, this term here is the prior. And it's the probability of the hypothesis before the data, prior to the data, hence prior. And right here, this is the posterior. So this is our belief in the given hypothesis after observing the data. Yeah?
How do you have the probability of the hypothesis before?
Good question. And so that's actually like a hugely complex subject in Bayesian statistics. It's not always complex. And we'll get into a concrete example in a minute to kind of show. But often you have to make some kind of guess. And that can have an impact on things, which is also partially why I would be leery of applying it like to something like ontological views, like mathematically. Zooming out, why am I talking about this then? We're not going to be doing math to try to show if there's a God or not, but there are some really important lessons that we can learn from Bayesian probability that we can apply to reasoning about our beliefs and communicating those beliefs with others. So that's what I'm wanting to get. That's what I want you guys to get out of this talk, is a few lessons from Bayesian probability, as well as the coolness of Bayesian probability. All right, so let's get concrete. So I have this dice problem, all right? And here's the scenario. You have a bag with 5 dice in it, a 4-sided dice, a 6-sided dice, an 8-sided dice, 12-sided dice, and a 20-sided dice. and you're in a room with another person, and the other person, without you looking, draws a dice out of the bag, and they're going to then roll it some number of times. So they draw the dice out, you can't see what it is, they don't tell you what it is, they set the bag aside, and then they start rolling the dice. And then they tell you what the numbers are that's coming up as. So they might roll the dice and say 6, 6, 5, 19, whatever. And so the problem is, what dice do you think it is based off of the data, based off the rolls? So let me go to my little program thing. Okay, so here's the situation. We'll get into Bayesian networks again, but basically here's what we have. These are our 5 hypotheses, all right? The D4, the D6, the D8, the D12, and D20. Those are our 5 hypotheses for what is the cause of these rolls that we're getting, you know. So right off the bat, what do you guys think? Let's say there's no rolls happened. What dice do you think it is? It's back to Grace's question, right? What do you set your priors as? Now, I think it's the right thing in this case is to set it to a uniform distribution of it's 20% each, right? That's so
I'd
if
say it's a little bit towards the lower numbers though, because the
because of the arrangement.
So I'm gonna say 8, because there's more chance.
There you go. Yeah, assuming they're evenly distributed and maybe they're the same size and all that, probably 20% is a good guess, but. It's good to question assumptions. Okay, so let's see. Let's just why is this not scrolling? Yeah. So if we calculate, and this is probably too small for you guys to see, perhaps. Let me see. That's not going to help a lot. Anyway, I have calculations here. I've got a link to it afterward if you want to look at it in detail. To this page, but so if you calculate the probability that, so given that we rolled a 6, all right, what's the probability that it's each dice? So what's the probability? Can you guys tell me what's the probability that it's the 4-sided dice? Yeah, it's 0%. That one's easy. And if you look at, and sorry, this is kind of small, but basically you use Bayes' rule here. You say, okay, what's the probability? And you go dice by dice. So let's just say for the 6-sided dice, let's try to calculate that's probability. So the probability of D6, given that we rolled a 6, is equal to, and that, again, you flip it around, it's equal to the probability of a 6 given that we have the 6-sided dice times the probability of the 6-sided dice coming up divided by the probability of getting a 6 from any dice. And that's how you calculate it. And you do that calculation, and you come out with 0.392. So about 39% probability that it's a 6-sided dice, given that the first roll was a 6. Now, what do you think? What do you think the probability is like roughly for like the 20-sided dice? Do you think it's like close or lower, higher?
Lower.
Yeah, it'd be lower. So you can do Bayesian probability in your head. It's natural. Maybe you can't get the exact answer, but was there a question? No. And actually, the equation kind of simplifies a little bit because the probability of getting like D6 here is the same as getting D20. So when you do each dice, and the probability of getting the 6 is the same. So the only thing that differs is basically the probability of getting that dice given, or getting that number given the dice you have. And obviously for a D6, it's a 1 in 6 chance. For a D8, it's a 1 in 8 chance. All the way to the D20, you have a 1 in 20 chance of getting the 6. So that's kind of how it works. You can kind of ignore the programming here. It's called a Jupyter notebook. By the way, it's actually like an executable. It's actually like executable code that produces everything that you're seeing. So you can actually run it on your computer and everything. So it's kind of that's why you're seeing code up here. Anyway, to graph what this looks like, this would be what we look like, what our prior looks like. Okay, makes sense, right? It's the uniform distribution, 20% that we have, that is each dice. And then this is our posterior after we rolled a 6. And you can see the 6 dice is the highest, right around 0.39. The 4 is 0%, and you can see it drops off the higher up you go, which is, basically what we would expect. Any questions on that? Okay. A little more code. So then I wanted to do it where we update it for roll after roll. So this is for the first roll, just same as this graph up here, just slightly different shape. So let's say we get this series of rolls: a 6, an 8, a 7, 5, 4, 13. What does our probability distribution look like? How does it look getting updated for each roll? And this is what it looks like. So for the first 6, it's this graph we already looked at. You roll another 6, it looks like this. You can see probability of the 20 getting lower and the 12 getting lower. Then we roll an 8, and the 6 drops off, of course. 0% chance there. So the probability that's the 8-sided dice goes up. Keep rolling, a 7, another 7. You get a 5, and, we're pretty confident that it's the 8-sided dice at this point. Get a 4, and even more confident. And then last we get a 13. And that, of course, invalidates all of our other hypotheses, which makes sense intuitively. And it's kind of cool because it's a mathematical demonstration of the Sherlock Holmes saying, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. So it's kind of cool. It's intuitive. Bayesian probability is very intuitive. At least I think so. So that's kind of like, that's the basics of how it works and how you apply it. Now, where is it actually applied at? As I said, I kind of got into it through artificial intelligence. There's all these algorithms out there for helping robots move around and that kind of stuff. And so one problem with robots is localization. So knowing where you're at in the world. So imagine, for example, imagine a robot that it's blind, it doesn't have any camera, and all it has is a couple directional sensors. And it's moving around a room. And, it's kind of learning the space. And, it wants to maybe know the map, the layout of the building that it's in. And you can imagine in different places it's going to have different measurements. It's just on ground level, let's say, and it's taking, let's say, infrared readings to get distance, or ultrasonic sensors or something like that, or a LiDAR, and it gets the readings. Now, there could be a number of places where the reading could be exactly the same, potentially. I mean, you might have like a hallway where it's like kind of rectangular and another hallway where it's kind of rectangular. And so, and also you can have errors in your readings. Errors happen in the real world. Like particle filters is an algorithm based on Bayesian probability that is used for robotic localization. And basically what you're seeing here is each of these little dots in this first diagram represents a probability distribution of where the robot thinks it could possibly be. So this is kind of like that uniform distribution right here. Remember, like in the dice problem? You can see there's kind of evenly distributed dots everywhere. It takes some readings. That's data. That's kind of like that first dice roll. And it sees, well, based on what I've seen in the past, I could be in any of these places. And then it takes some more readings, and then it's pretty sure where it's at. So that's like kind of place where Bayesian probability is applied at. Actually, I have a LiDAR coming in the mail pretty soon. Like a couple years ago, I was looking into this stuff, and it was like $8,000 for a LiDAR. I was like, oh, man, because I was wanting to make a robot to go around my house, and I was like, man. And then like this year, there's like this Kickstarter that made them for like $300. I was like, sweet. So we'll see what happens after I get that. But that's why I'm into this kind of stuff, kind of. Okay, and now I want to introduce the Bayesian network concept a little bit. It's pretty intuitive. This is the same graph or network I showed you in the dice problem. I got to take my jacket off because This is serious stuff. So basically, it's just saying, here's a variable or an evidence we've seen, the six-sided dice, and these are the hypotheses that point to it. The arrows indicate causation, not conditional probability. So like this is conditionally dependent on this. These are all conditionally independent, right? Because if you know it's the 20-sided dice, then you know it's none of the others. So that's kind of, it can be confusing, but that's what it means. It means causation, not conditional probability. If you look up Bayesian networks on Wikipedia, this is the Bayesian network that comes up. It's kind of a common one for learning and stuff. And kind of the way to read this is, basically rain influences if the grass is wet or not, sensibly enough. If it rains, good chance it's going to be wet grass. And it also affects the sprinkler because the sprinkler has sensors to not come on if it just rained. Don't water the already wet grass. But there's probability of failure if it rained. So like in this is saying if it rained, there's still a 1% chance that the sprinkler could come on, and a 99% chance that it won't. And if it didn't rain is false, then there's a 40% chance that the sprinkler will come on. And you can see, because the sprinkler is taking into effect rain, it's dependent upon rain. Rain causes sprinkler to come on, or it has an influence on that. You might say it causes it to come on if it doesn't rain. And both of these, of course, influence the wet grass variable. So having a Bayesian network like this, it's a really useful tool to kind of graph out this could be used to graph out your beliefs, for instance, or whether they're like ontological view beliefs or, is the grass wet or whatever, any kind of thing. And I'll give a couple examples of that. You can use these, by the way, in all kinds of crazy ways. So you could even ask a question like, what's the probability that the sprinkler is on given that the grass is wet? Those are more complicated to calculate. So like this is what it looks like to calculate that question for the Bayesian network. Did it earlier today. I'm usually kind of lazy, and I like Monte Carlo simulations because I'm a programmer. And basically this is another solution to it where it's kind of cool. You can basically just, it's like throwing a dice a bunch of times. You can get a bunch of random numbers and simulate rain happening, simulate the sprinkler happening given the rain happening, simulate the grass being wet based on those, and you can just count up all of the number of occurrences and find the probability that way. It's a really lazy way to do probability. It's really powerful. Actually, I think I have, let me see. So you can see what it looks like when it runs. So you can see it's doing a million simulations. You can see rain equals true or false, sprinkler equals true or false, grass wet equals true or false. And then once it gets to the end, it simply counts them up and divides by the total number, and you get 0.646, which is the same thing you get doing it the analytic way. There's a bunch of other really powerful ways of solving Bayesian probability questions. One of them is called Markov chain Monte Carlo. It's an incredibly powerful algorithm for solving Bayesian questions, basically doing stuff like Monte Carlo simulations. So this is an example Bayesian network that's used, I believe, to price car insurance. You can see how things like socioeconomic status factors in good student, age, driving skill, however you do that, theft, blah. So that's an example application of Bayesian networks. This is another one that looks crazy complex, and it's used for diagnosing medical conditions. And you can imagine there's probably tons and tons of variables in that. Okay, so now that we know kind of roughly what Bayesian probability is, how can what are the takeaways that we could use for understanding our own beliefs and communicating those with other people. So there's three big points that I want to kind of highlight. The first one is assigning degrees of probability rather than Boolean values to various evidences or observations, or however you want to put it. The reason for that, well, that's how Bayesian probability works, right? Like when you first see the dice, you don't say, well, I think it's my best guess, I got to guess one. Okay, I think it's the six-sided dice, all the others are false. That would not work very well. If you did that and you did the math, like you'd be getting all this new data and you'd be multiplying by 0 and it would stay 0. It's not very good. So you're kind of, by resolving something into a true or false value, a 0% or a 100%, you're throwing away that hypothesis. And you will not consider any more data that comes your way. And that can be problematic. The other one is to use networks, kind of like Bayesian networks and graphs, to show the relationships between your various hypotheses and variables and evidences, and because they do influence each other. And then the last is to doing the Bayesian thing and update your hypotheses based on evidence. Keep an open mind, and factor the new evidence in to all of your hypotheses. Don't just, not just one. Try to factor it into all of them. So, kind of to give an example to kind of go through that. And this kind of shows how it could be useful for communicating. So if you say, "Hey, Caleb, I'm an atheist," and I'm like, "Hey, well, I'm not an atheist. I'm a theist." There, that's not very useful. That's not very helpful. We're being very imprecise. So like we can draw a network and try to show where I could draw a little network to show, so this is just theism. Yeah, I'm a believer. But this is kind of what I mentioned before. It's the whole. I see it as two other variables, which, excluding the ones like the computer simulation and Boltzmann brain, you're kind of left with universe is eternal, or the universe spontaneously popped into existence. And I might have a conversation with someone and they say, well, I think the universe is eternal, or they may say, well, I think that the universe did just spontaneously pop into existence. And obviously there's a lot of people who believe both of those. And then maybe I would say, well, I don't think so. That's not very helpful either. It's keep on adding to the network. So I would say, well, maybe rather than saying, well, I think so, I would say, well, I think so because the second law of thermodynamics states that we should be in heat death if the universe was eternal. And the first, I would say, I don't think it spontaneously popped into existence because the first law of thermodynamics says that matter is neither created nor destroyed. And so then someone might say, well, I don't think the second law of thermodynamics or the first law of thermodynamics applies everywhere, or something like that. And so you could say, you could draw in your own. You could say, here's what I actually think there is a super universal physics that we've never observed, and that's what I base my belief in one of these two off of. So I hope it kind of demonstrates, this. You can kind of keep on doing this. You can kind of keep on showing how your beliefs connect to each other, and that can help communicate things. Because like I look at this and I can say, yeah, I mean, like I said, we don't know everything. There could be some super universal physics that we've never observed, right? But it's also, I think, worthwhile mentioning that just as I have never observed God, you have never observed this super universal physics that allows for the second or first laws of thermodynamics to be violated. So it's not to say it's wrong or right? It's just, let's come to a pool of shared understanding. Let's show all of how we got to where we got. And you can keep on doing this kind of thing. observations, evidence. And then you can get to a bigger graph like this. This is kind of one I just drew, and it's pretty big, but it's still, the thing is, it's extremely limited. There's so much else that each of us considers beyond these variables. You have things like the ones I just talked about, universe eternal, universe spontaneously generated. You have things like Darwinian evolution, young Earth creationism, fossil record, is the Bible reliable, other religions, feasibility, etc. Philosophical stuff. And so I think that things like this can be helpful to, like I said, it's not very helpful if you just say, well, I think this, and no, I think this. It's better if you can show where you're coming from. And it doesn't mean you're going to come to the same understanding or the same belief. But I think it can help to logically communicate those beliefs. So in conclusion, just to go over those three things I wanted to really, concepts to pull out: assign degrees of belief, degrees of probability rather than Boolean values. Unless you know a whole lot, you probably cannot assign 100% probability to anything. One example I like to use is, I can't say for sure that my wife is not a serial killer. I'm very confident that she's not, although she does like crime shows a whole lot. There's an insurance policy. No, I'm just kidding. But I can't say that. I mean, it would be incorrect for me to say, yeah, I know 100% she's not. And doing so can I think it comes off as either being arrogant or ignorant, because I think it's more truthful and intellectually honest to assign probabilities between not 0 or 100, but somewhere in between, because doing so implies a lack of knowledge, which we indeed do have. We indeed do have a lack of knowledge. When you assign something like 100%, you say, yeah, I've written this off completely, you're basically saying you know a whole lot to make that. And I would say you probably don't. And I don't. I can't say hardly anything with 100% certainty, if I'm being completely honest. And also, like I mentioned before, doing so, assigning like a 0 or 100% probability, well, mainly a 0%, it can make you prematurely throw out a hypothesis that could end up being true. Like if we had thrown out the 20-sided dice hypothesis when we rolled that 13, it wouldn't have made any sense mathematically. And then again, use networks to show how various variables influence your beliefs. It can also help analyze our assumptions. Like with the Monty Hall problem, we could have drawn that out. This is why I'd say it's 2/3. And it also helps to keep the big picture in mind when you have the graph of everything that's happening. And then last, update your beliefs based on evidence. Keep an open mind. Consider evidence that doesn't just fit your best guess, but all of the hypotheses that are out there. If you're really big into the 6-sided dice hypothesis, and you were out there reading blog posts saying, yeah, we found we got a 5-sided roll, baby, and and you're ignoring the 13-sided dice articles, that would be bad. And again, it just kind of also as a last reminder, it's good to question assumptions. As one last question, what if I told you that we rolled a 13 and it was the 8-sided dice? What would you think?
There's a chance that the 8-sided dice has got a bunch of random numbers and one of them's 13.
Yeah, I never said it was numbers 1 through n. Let's question the assumptions. And that's it. A couple links here for you for extra information. The page I was showing is right here. But yeah, do you guys have any questions?
Did you crank out a program? This program's really cool, like on who to vote for today? Because
I did not. But it's that's politics. It's kind of fitting that it's today. It's like that's one of those other things where it's like you have all these completely maybe not all these completely logical people, but in general, people are pretty logical. But you have people coming to such strong conclusions and different sides, and it kind of shows how like there's all these underlying assumptions. Like it seems like they're usually logical, not always, but yeah, it's crazy how we can come to such different beliefs with the same information, but then again, it's not always quite the same information.
How would you know, like, sometimes on the other side, I agree with the true-false thing, that to not take that out to zero, but how do you know whether some things like pretty false, like 1,001 versus like 1 billion? Like, I mean, do people work on this?
I don't really know, like, and it's tough. There's so much subjectivity. Like, so going back to the computer simulation theory that Elon Musk recently stated was 1 billion to 1. Like, it's so complicated because, so here's his argument. I mean, I haven't read it, but I'm assuming this is his argument. If it's possible to create a computer simulation that is powerful enough to simulate a universe, obviously people would do it because that'd be really useful for figuring out social issues, what kind of laws work the best and don't lead to like meltdowns of society. Obviously it'd be super useful if we could simulate a full universe, right? So people would do it. And it's so much easier to simulate a universe than it is to, well, create one, that the probability is there'd be millions or billions of these simulations, and the probability is, based on how much time the universe has been around, it's probably already happened. So, you know, that's the assumptions, and from that reasoning, it seems kind of logical to say it's 1 billion to 1, but those assumptions, it means that's a huge assumptions. For instance, I don't think we'll ever be able to build the equivalent of human in a computer. I think we may get all the same neural connections, but, well, as a believer, I think there's a soul and all that. So I don't think we'll ever come to that. Hence, I don't think the first assumption is true. Hence, I don't think we're in a computer simulation. So it's like, I don't know, it's hard to say how you could assign those probabilities.
One problem with an assumption, like the argument for simulation, is that you said how long the universe has been around, but if it's a simulated universe,
then you wouldn't know. Yeah. Yeah, it could be, it's always been around. It could be completely different physics, too, right? It doesn't have to be using the same physics. Yeah. So, I don't know.
I think that recently, it's actually so Elon Musk came up with it. It's the British philosopher Nick Bostrom or something in his book, Superintelligence. He actually proposed that.
Oh, interesting.
And I think Elon just repeated it.
Oh, Elon's definitely not. It's not new. It's not a new idea to him at all. No.
And also, I think wasn't that the Reverend Bayesian actually came up with his theorem specifically to discuss the probability that people will allow them up?
Yes, you're right. Yeah, he was a reverend, and I think that was his goal. Mm-hmm.
Yeah, and he also specifically used it to discuss if there was a God.
Mm-hmm. Yeah.
But I don't know what he can.
Yeah, I never looked into those studies he did, or writings. Yep. Any others? Yeah, Jason?
I guess more of a statement. We talked about this right before you started. Richard Carey does have an entire book proving history about using Bayes' theorem to examine the historical Jesus question. And, you know, spoiler alert, he he doesn't think Jesus existed.
Yeah.
That Herman in the debate, like, said that somebody asked Bayesian probably was in the questions, right? And then he just kind of poo-pooed it and said you can't really use that. But that didn't explain why he didn't like Bayesian probability.
He said that somebody, and I'm not familiar with the work, but he said somebody else used Bayesian analysis to prove that Jesus did exist.
Right.
So the problem is you could use the same tools and come to completely different.
And Carrier's answer, and we did the
Right.
podcast after the debate. His explanation of that was, and again, I don't remember who it was, but it was someone who was not using Bayes' theorem correctly, is not a mathematician, is not a historian, and he said it's like how William Lane Craig uses logic to decide that the Earth is only 6,000 years old. Just because he can use logic incorrectly and come to that answer doesn't mean logic itself is flawed. It means he doesn't know how to use it.
Well, and it also is that Carrier's book is peer-reviewed in the field of history, and who's the other guy
he's talking about now.
Yeah, I don't know, like, whatever, the Christian that's using it never went through the peer review process, never went through the professional process to back up his claims, and that's peer review's arguments. He uses fallacy, and, you know, I can see that. You know, if you're incorrect in using format, and so, you know, like, you can come up with anything. So, you have to have a pass peer review.
But the fact is also, you don't have to be abusing it per se. You don't have to be misapplying it. You can just have incorrect assumptions, or different assumptions. Yeah, and that's all you need to be way in a very different conclusion.
The same flow chart.
Right.
Depending on the numbers they plug into it.
Yeah.
They're going to get completely different. That's why this is, for questions like this, that's why you can use it to kind of show how you came to your beliefs, but it's not going to be very good for convincing anybody else.
Right. It's not good. You can't really do the math, I don't think. But I think it's still a useful tool for, like I said, communicating. You know, I'm not. Yeah.
It's cool to see how the robots use this. I mean, that was pretty neat.
Mm-hmm.
Like you knew even with a few samples that it wasn't in one room.
Yeah. Yeah. Yeah, and a lot of this is, I think, a lot of what's behind a lot of the really big advances recently with the self-driving car technology. So it's definitely a very hot topic right now. A lot of cool stuff coming out of it. Almost all the recent voice recognition, or a lot of AI is based on this.
I mean, probably the simplest statement that sort of incorporates the whole base thing is Carl Sagan's statement that extraordinary claims require extraordinary evidence. If your prior probability is very, very low, you need to have some pretty strong evidence to overturn that low initial probability.
Yeah.
And that's sort of a Bayesian approach.
But it's interesting because, you know, what are your priors, right? Like Occam's razor, for instance, is really useful, but sometimes it can actually be circular reasoning. For instance, if someone says, well, I put like, let's say you're talking about, did Jesus rise from the dead? And they say, well, miracles we never seen a miracle, so we put a really low probability on that, and, you know, therefore, the most likely, well, you know, it's the most likely, the simplest solution is probably the one that it is, and they just forged it. But then someone on the other side might say, well, I mean, it's not many steps. It's very simple to say God just raised him from the dead. Like, so, and a person's Bayesian network, there's so many things that would factor into what they think the simplest solution is. So, yeah. Any others? Yeah.
Yeah, thanks for all the time and effort on it. That was a really interesting talk. I appreciated all that. I'm not exactly sure if I have a question to formulate or what, but my mind's kind of going around and around that. Your last three and your middle one is those things that influence our our network, that come to bear upon our beliefs and kind of being more consciously aware of what those might be. And I was thinking of, I couldn't read all when you kind of exploded out and you had a lot of different circles, I couldn't read any of those, but I was thinking of people's early childhood as a good example of that. It has nothing to do with thermodynamics or anything, but if you were in a very free-thinking or perhaps a very repressive, fundamentalist childhood, that is going to set you on a path, perhaps, And so that's one thing that started to introduce the idea of subjectivity to me and what you were presenting. And then another place, I read a quote recently that just keeps sticking in my head, which is that the veil between theism and atheism is very thin. And what this writer was getting at, and I've seen this in quite a few different places and things I've read, and I'm going to try to frame it maybe in terms of Bayesian probabilities. If you start to strip away and let fall away some of the highly improbable claims of religions, you end up, of particular religions and particular belief systems, you end up with a pretty small core of things that, given a religious worldview, have a higher probability of being true. And if you kind of take that thin veil and put atheism and secularism on the other side of it, and condense down some of the most commonly held and the most likely to be true propositions from that, they end up being really similar to each other. And I guess I'm just curious if you've run into anything like that. I mean,
As in me
has that
personally?
ring a bell with you at all on anything that you've run across in your readings?
Not necessarily, but I think there's some truth to it. I think that it's often a fine line between belief and unbelief. It seems like if you get down to the really core, kind of like what you were saying, like what are the big things we can actually look at? I don't know.
Yeah, I don't know if that resonates with anybody else. I think Brad, you and I had a conversation at Brian's house one time where the secular explanation for the origins of the universe starts with an almost infinitely densely packed, I don't know, what is it, energy and matter or something like that, and all the matter in the universe is like in the thin size of your pinky nail. It's not too hard to say, right, that's God, or to say, no, it's not, that God has nothing to do with it. That's kind of what, sort of what I'm getting at, maybe. So I don't know.
I'll see that nothing, something, right? But a substrate for something to come out. So whether it's the Big Bang and whatever cosmos was behind the Big Bang, or God and whatever causes God, you've got a substrate of something, nothing happening, something happening, and timelines that nothing something. Whether it's Genesis or you know what I mean?
Yeah.
I think he's talking about getting at different things.
Yeah. Well, let me actually. So I had a thought somewhat recently that's really close to that. So I was reading more about the computer simulation theory, and I thought about how, man, that is like really close to what I believe as a believer in God. It's like you believe there's this being that is so powerful they could just create something. Like I'm imagining some programmer sitting at his computer and saying, "Let there be light." It's like, and the idea that often people, it's like, well, he couldn't have done it this way or this way, but I mean, that would be like saying, well, that programmer couldn't. If you look at the universe, it looks very old. Now, I'm not a young Earth creationist, but if we were a computer simulation, I bet you we're not 14 billion years old. We could be, but it's believable that we could not be if we believed we were a simulation. So that's kind of like the line between believing in a computer simulation and believing in God doesn't seem very big.
I think there's a book, I don't have enough faith to be an atheist, and I believe that the author of that book is David Herman. I'm not sure, and I've not read the book, so don't hold me on its validity. But it's similar, like at some point you just keep asking why or how you're going to get to that.
That sounds like great comfort. He always says that, but maybe it's
I'm not sure who did it, but eventually if you just keep asking why or how, there's going to be something where there's got to be some amount of, again, an assumption.
Yeah.
There's either that massive ball of energy that has always existed eternally, which is not so indifferent from a universe that has existed for eternity. So I think I see what you're saying. At some level, there's got to be some cliff.
Yeah, Grace?
Once you get to that level, so how you were saying, like, stripping away, like, the unfoundable aspect of religion, what you're really doing is you're leaving only the untestable claims. So, or you're moving the goalposts. And you're creating a placeholder for, instead of just saying we don't know. Because there are like multiple falsifiable explanations, God, simulation. And so what you're saying is that there's no difference between there being a high probability for something and just not being able to prove it's false. And so if you're going to choose an explanation, you can't. You have to say you don't know.
Yeah, I mean, I'd say, you definitely don't have enough to say for sure. Like, I mean, it's like I said, when I've looked at it, it's like there's really hard questions on both sides. Ultimately, you're probably going to choose something to live your life by. Maybe that is, I just don't know.
Or I want to find out. Your deciding method.
I like
Yeah.
that quest for knowledge. And see, what to me is a big part of your presentation tonight that I find really attractive is that you look for more data. You want to understand more. I think we could probably all say, no matter what age we are in this room, within our lifetime, these macro level questions about, you know, thermodynamics or a universe spontaneously generated, the solid answers are still not going to be had by science, but you want to progress towards that. We have the longing to know, and too many religious settings are fear that.
Yeah.
And repress that, and I think that's so you're giving us an approach or a worldview or a posture for communication and dialogue with people that's really helpful, especially when it's reciprocated on the other side of the conversation.
Yeah, and you know that quote that I gave you, Brian, 2 Thessalonians 2:21, 5:21, 5:32. Yeah, you know the Bible better than I. What's this? Test everything, hold to what is true. That's in the Bible. So if you're wanting to get someone to think about something who is a believer, that's something you can definitely use. But I just think it makes sense. I mean, if it's true, there's no harm in questioning it.
Just everything hold to what's probably true. That's
right. That's right. Yeah.
And that's not a subtle difference, you know.
Yeah. Well, one thing that you said that I wanted to mention, like you were talking about childhood and everything, or how that could affect things, and like I had this little I want to believe factor in my little graph, my X files factor. But there's, that's just an example of, like I said, this is very limited. Like, there'd be so many, though, there'd be so many things that we would experience. Like, emotions can play into that, and what we want can play into what we actually choose to believe. And there's so many variables. And that's why I'm not trying to do math with this. But yeah.
I wonder, some people could journal or write their beliefs or something in a very linear fashion and get kind of stuck. Do a paragraph 2 or get word jumbled and screwed up. If they did a map like that, I think it would be a much more macro kind of perspective and maybe untangle some of that. But I also wonder if there's networks like that where it might be a little causally connected, and there'd be some parts of that map that will almost show up in red with an emotional charge. Almost be a scary part of the logical network to go to due to either previous experiences in religion or possibly things they had with family. So I wonder how many people are holding beliefs that they partially hold and are afraid to really visit or test.
Cognitive dissonance.
Yeah.
So,
if you hit somebody with the fact, I know what I believe about that, they don't see how even their own life is connected or what it really, how reliable it really is even then.
Right, and the good thing about this also is, like I said, it seems like people generally do think in a Bayesian kind of way, but I think often they don't do so perfectly. And maybe drawing it out could help, because like you said, maybe you could show a line like, wait a second, this is affected by this, but why are you not considering it? So yeah, good point.
So even 2 arrows on there, like Hegel could write 500 pages on it, just, and just get totally bogged down. And,
oh yeah.
You know what I mean?
Yeah. And like everything's related, like not just the ones, like I was saying, the arrows don't imply conditional dependence, like, because almost all of these are conditionally dependent, right? I mean, if you, if you believe there's no God, for instance, this one, or this is false right here, let's say, then your belief in the spontaneous origin of life goes way up, right? You need something to start it up. So everywhere, everything's connected, and it's very complicated, sadly. But I think still worth talking about.
So what those 3 Baptists say when you hit them with this?
I don't think I actually pull this out, but yeah, we're still talking. So.
Oh, seriously?
Yeah, I mean not right. Yeah. It's just trying to do some studies. So, but we'll see. Any other?
Thank you. I've been actually teaching thermodynamics like for 3 weeks now or something. So that's sort of like the first look at that. First law, the second law.
Yes, nice. Yeah. Any other thoughts, comments, questions?
All right, everybody's welcome to hang out and talk and chat as much as you'd like.
All right.